Hello, my amazing students. This is Mrs. A, and we are on 9.3, Simplifying Expressions Containing Square Roots. So we're going to use our product rule and our quotient rule. And remember that our product rule simply says that if we have the square root of x times the square root of y, since our indexes are the same or our indices are the same, that becomes the square root of x times y. So we can take two separate radicals and put them together into one radical with the product underneath if they are the same index. Okay, so we're going to do that with this one. We've got a square root of 7 times the square root of 3. Since they're both square roots, we can make that the square root of 21. And there are no perfect squares in 21. So this would be our final answer. Okay, so down here we've got the square root of 5, the square root of g. When we put them together using the product rule, we get the square root of 5g. And again, there's no way to simplify that one. Here we've got the square root of 45, which with the way that I like to do them, I like to always split them into the largest perfect square that you can find in that number, and then the leftovers. So 45, the largest perfect square that's in 45 is 9. And so then the other one would be a 5. So 9 times 5 is 45. And then this one, this one is going to wind up being a 3. So we get a 3 square root of 5. And that is the answer. Square root of 72, the largest perfect square we can find in 72 is 36. So 36 times 2 is 72. This 36 becomes a 6 outside the radical, so our answer is 6 square root of 2. So now we are going to break apart the 12 into the square root of 4, square root of 3. The square root of 4 becomes the 2 outside the radical, so we wind up with 2 square root of 3 is our answer. Square root of 15, there are no perfect squares in the square root of 15, so that one cannot be simplified any further. Okay, so now we're going to use our quotient rule. And our quotient rule says that we can take a big radical that has a fraction under it, and we can split it up into two radicals, and vice versa. We can go this way, we can go this way, and we will find sometimes it is a benefit to have it in this form. Sometimes it is a benefit to just go ahead and split them up. So for this one, since 8 and 49 have nothing in common, I would split them up into an 8 and a square root of 49. And then I would go ahead, I'm going to get this other thing off the board. Okay, the square root of 49 is perfect, so it's already a 7. But the square root of 8 can be split up into a perfect square of 4 and a leftover of 2. So the perfect square of 4 becomes a 2. We wind up with 2 square root of 2 over 7 as our final answer here. And this one, whereas this one had no benefit to keep it together, this one does, because we've got the square root of 25 over 5. 25 over 5 is 5. The answer is square root of 5 because we cannot get any simpler than that. All right, so now we have a problem that is a quotient, but I could see where this would be beneficial to go ahead and put under one big radical instead of split radicals. So I'm going to go ahead and put them together. That gives me the square root of 12, because the 120 divided by 10 is 12, not 10, 12. And then 12 will break up into the square root of 4 times the square root of 3. And the final answer then would be 2 square root of 3. So I ran out of board. I'm going to put it right here. So 2 square root of 3 is the final answer for this one up here. Now this one, I see no benefit to keeping it together, so I'm going to split it apart. And I'm using my quotient rule the other direction. So the square root of 36 just becomes 6, and my final answer is square root of 5 over 6. Okay, so now we've got the square root of b squared. And again, at this point, we are leaving everything in assuming positive variable terms. So this is just going to be b. I no longer have to put that absolute value there right now. But since this is a square root, the square root and the square power are going to cancel each other out, undo each other, and give me a b. This one, I'm going to look at it and say, hey, that is already completely a perfect square. 100 is 10 squared, and a to the 4th is a squared squared. So this is going to become 10. Since it's already perfect, I'm not going to write it again. 10a squared. So basically, remember that this is an understood 2. And to simplify that, 4 divided by 2 is 2. All right, so on the next one, we've got a variable that has a perfect square, but our number in front is not. So I'm going to break this into what's perfect and what's not. And 24 has a 4, and it has a p to the 8th, which is perfect. And then I put my leftovers over here, which will just be the square root of 6. So this will come out of the radical as a 2p to the 4 square root of 6. And that would be my final answer. Down here, we've got the 27 is not perfect. And the square root of g to the 6th is perfect. So the square root of g to the 6th will become g cubed when I pull it out of the radical. And then the square root of 27 would become the square root of 9, the square root of 3, because 9 is perfect and 3 is the leftovers. So then my final answer would wind up being 3 square root of 3 over g cubed. And since I've run out of board, I'm just going to take my square root of 9 and make it a 3 and box my answer. So now we start with some variables that do not, that are not perfect squares. So this is the square root of m to the 9th. I can split that up into the square root of m to the 8th, which is even, and therefore a perfect square. And then the leftover, which is m. So now the square root of m to the 8th is m to the 4th. And then I tack on the remainder. So I wind up getting m to the 4th square root of m. Down here, I'm going to break this into the square root of t to the 12 times the square root of t to the 1. Remember, you don't have to put that 1 there, but it is understood. And then the square root of t to the 12 is t to the 6th. And then we tack on the square root of t. And that is that one. And here we have another board where we need to split up the k into a perfect square, and what's left over, k to the 5th is k to the 4th, and then times, I wrote that really big, times the square root of the leftover, which is k. So when I multiply these together, they still go back to k to the 5th. But when I bring this out, I get k squared coming out. 4 divided by the 2 is k squared. And then I tack on the k. Now, the number is good. The variable needs a little work. So this is going to be square root of 49. And v squared is perfect, so I'm going to put v squared here. And then I'm going to tack on the leftover v. Okay, so this is a perfect square now. And this is what's left over that will make these multiply to this. So the answer is 7v square root v. All right, so now we're working some more on simplifying radicals. And we're going to break this one up into a perfect radical and what's left over. In 32, 16 is a perfect square, so we're always looking for the largest perfect square that's inside that number as a factor. And then left over is a 2. M to the 18 can go here, and m to the 1 can go over here. So once I've split it up appropriately, then the square root of 16 is 4. The square root of m to the 18 is m to the 9, and all I do with this one is tack it on. So that's just going to be the square root of 2m. Down here, I'm going to break this one up into perfect and leftover. 18 has a 9 that's perfect and a 2 leftover. M to the 7th has an m to the 6th that is perfect with an m leftover, and n to the 9 has an n to the 8, I don't have much room here, n to the 8 that is perfect, and an n left over. So this one comes out of the radical as the square root of 9 is 3. The square root of m to the 6th is m cubed. The square root of n to the 8th is n to the 4th. And then I tack on my remaining radical to m n radical. Okay, so on this one, we have the radicals together, but there's no benefit to having the radicals together. I would go ahead and at least think of them as separate radicals. So I'm just going to make them separate right there so I save my board space. Now, in the denominator, I'm going to have the square root of g. Okay, the square root of g to the 12 is already perfect, so it's going to come out as g to the 6th. And this one is going to be a perfect and a leftover, so the 3 is definitely a leftover, and f to the 8 is perfect, and f to the 1 goes in the leftover stack. So now we're going to have f to the 4, when I pull that out, square root of 3f, which I just tack on the leftover radical, and g to the 6th. Now we're using our product rule. We have no good reason to keep these apart, and if I put them together, I get the square root of 16b squared using my product rule, and that is a perfect square. So the answer will be 4b. Okay, these I'm going to go ahead and combine because they're both square roots. So I'm going to get 18 under the radical, and then x to the 5th times x is x to the 6th, and y times y to the 4th is y to the 5th. After I multiply them together, I'm going to split them apart again into my perfect radical and what's left over. So perfect in 18 is 9 with a 2 left over, and x to the 6 goes in here, and a y to the 4 goes in here with a little y left over there. And then this one comes out of the radical as a 3x cubed y squared. I'm going to erase it. 3x cubed y squared, and then tack on the radical square root of 2y. So here's my answer down right here. Okay, so 3x cubed y squared, square root of 2y. All right, so on this one, I do see a benefit for putting these back together under one radical. So let's just go ahead and take this radical off, and let's make this radical grow. Okay, so we're going to make this, well, that was an odd one. Okay, so we're going to put these back together in one radical. Now, 36 divided by 2 is 18. And r to the 7 divided by r to the 3 is r to the 4. Now, I will split this up into perfect and leftover. So there's a 9 in 18, and there's an r to the 4. And then we have a leftover 2. To get these two, this product, to equal that. So my final answer here is going to be, when this comes out, 3r squared, square root of 2. 3r squared, square root of root 2. And that would be my answer. Down here, I can also see a benefit for putting these two back together again. So we're going to take the bottom radical off. We're going to extend the radical down and make it one radical. And now we can divide the 18 by the 2 and get the 9. The x to the 7 divided by the x and get the x to the 6. And now it's a perfect radical. So that's going to be 3x cubed. And that is the final answer on that one. And this is the last little board for 9.3. And we put them together. There's no benefit in keeping them apart. So when I put them together, I get square root of 20k squared. Square root of 4k squared will be perfect, and square root of 5 will be leftover. So my final answer is going to be 2k. 2k square root of 5. There it is. Now this one I would definitely put together, because when I put them together in one radical, I get the square root of 25b squared, which is perfect, and it will pull out of the radical as 5b. And that is the end of 9.3, and this is Mrs. A, and may God bless your day.